Hi, my name is Brad Garner. I'm a hydrologist with the United States Geological Survey in the Arizona Water Science Center. And it is my pleasure today to get to talk to you about water. But thinking about who you are and what you might be thinking about today, it occurs to me you may not know a lot about hydrology, and that's fine. You may not know some of the words that I use in my everyday practice, like riparian evapotranspiration. So I take it as a challenge to try to reach you without using words quite as big as that. I ask only for your patience, especially if you do know something about hydrology. Some of this may seem familiar to you. But if you don't know hydrology, I ask only for your undivided attention. Maybe limit the number of pop-ups and tabs that you have open right now if you're watching me on a computer. So let's begin. Imagine that you're standing on the banks of the Verde River in central Arizona, but that it's not today, that it is last June, late June 2012, a dry, hot summer day. It has not rained in 2 months, and there is no snow melt left anywhere in the high country of northern Arizona. So no rain and no snow melt, and yet this river is flowing. It's flowing at about 32 cubic feet per second, 14,000 gallons a minute. Now I ask you, how can this be? Sure, we've all seen rivers flowing under these conditions, but where is this water coming from? Where do you think? If you thought or said the ground, that's a very good answer. This water in this picture here is coming from the ground, and we call this kind of water, when there's no rain or snow melt to obviously explain its existence, we call this base flow. Base flow comes from the ground, and humans can change it. Humans can change it. What do I mean by that? Am I talking about putting a pipe into the river and pumping water out? Surely we can agree that if you pump water out of a river, base flow out of a river, there will be that much less water available downstream. Common sense. Now I'm talking about something a little more obscure, less widely known, but nevertheless just as true. It's the ability for human beings, us, to pump groundwater from wells and change base flow in a river. Now, I realize that this is not necessarily the most intuitive thing. Groundwater is out of sight. It's in the ground. It's not in our obvious view. And I can understand how you might not understand this. There was a time in my life when I didn't understand it, and I'd like to tell you how I came to learn about how humans can change base flow. You see, when I was growing up, my family had this fishing cabin in central Texas. We called it the River House because not 200 feet from the front doorsteps there was this perennial stream, this river that flowed year-round. And of all the many things a young boy could love about a place like this, my favorite thing about it was this well in the backyard. We had this manually hand-cranked well, and I really loved this thing. But of course I was young. I didn't have any idea how groundwater worked, or really in a deep sense where this water was coming from. I just knew it was clear and cold, and it was our water supply when we were there. It wasn't until some years later that I came to find some basic facts about this well, some scientific data about this well. I found out that this well was 60 feet deep, but that it was only 30 feet down to water in the well. That is to say, lower measuring tape into the water and into the well until the very tip of the tape just touches the surface of the water, you would measure 30 feet. I also found out that it was 35 feet down from the very top of the well casing down to the surface of the river, measured vertically, just straight up and down. 35 and 30 are similar numbers. They're not identical. Interesting, but these were just numbers to me at the time. They had no meaning. They were just facts. It wasn't until a little bit sometime after that that I found out a bit more about how groundwater works. I came to learn that the ground is made up of rock and soil and sediments, and between all the spaces in the ground there is open space, cracks in limestones and granites, and individual sand grains that rest against one another, and there are open spaces between them, pores, if you will. And beneath an area that we call the water table, seen here as the beginning of the large blue area, everything beneath the water table, all those open spaces in the ground are filled with water. everywhere. And also this is a very common misconception about groundwater. I know because I had it once. You may share this, and let's dispel it from our minds right here and now. It's this: groundwater moves. Groundwater is not a static phenomenon in the ground. It's not like a pool that just sits there waiting to be pumped, doing nothing else. With exceptions so rare that they don't even merit mentioning today, groundwater, every molecule in the ground is moving from one place to another. Now, in the case of my river house here, it was moving toward the stream, toward the perennial river down below, to discharge as base flow. Base flow comes from the ground. And you could see this, just like you can in the Verde Valley and in the Verde River. You could see, walking along the banks, this water coming out, discharging as springs, flowing a short distance into the river. And you could also, I remember wading out on a hot summer's day into the tepid waters and feeling this cool inrush of water at your feet. This was groundwater coming in. This was base flow coming in. And so then I thought, what of this water that I would pump? You know, what of the old porcelain pail that we had, the gallon pail that we use for our water supply? Say I pump a gallon of water out and I hold it here before me, and I look at it and I ponder it. Moments ago, every drop of water, every molecule in here was in the ground, and it was moving toward the river to become base flow at some point. Don't know when. Groundwater moves very slowly, but it is not in the ground anymore. It is now in my pail. It is not moving toward the river. It is here. I have changed the system. It therefore follows, as must day the night. It has to be this way. There's just no other alternative, that at some point in the future, there will be exactly 1 gallon less of water that has moved through that river system. I'm a human, and I have changed the system. And what I did was independent of everything else that was going on. It may rain more, it may rain less, but the fact that I chose to pump the well on that day has nothing to do with how much it rained or didn't rain. I have taken 1 gallon out of groundwater, and if moving groundwater is taken out, it won't get to where it was going. That's a pithy little thing to say, but it's surprisingly true. And as it turns out, this pithy little saying is one side of a coin of a concept we call stream flow capture by groundwater pumping. It's one side of the coin. We'll talk about the other side in a little bit. But now, about the Verde Valley. Everything we just talked about there was the subject principally of our investigation, the U.S. Geological Survey, in cooperation with the Verde River Basin Partnership in the town of Clarkdale. We wanted to know about how humans have changed base flow in the Verde River in the past, in the present, and what might yet happen in the future. How do you answer a question so big as that? How have humans changed a hydrologic system, a huge area of north central and northern Arizona?